So basically, this theorem here says if two angles in one triangle are congruent to two angles in another triangle, then the third angles of the triangles are congruent. So looking at the left triangle, which angle is marked with one marking? C. And what is C congruent to in the other triangle? Okay, so that's what it says right here. If angle C is congruent to angle K, and then in the top one, what is marked with two congruent markings? B, and two congruent markings in the other triangle is J. Okay, so then it tells that here. So if C and K are the same thing, and B and J are the same thing, then it doesn't make sense that those remaining angles A and L would have to be the same measure as well. That's what this is saying. If you know that two angles of one triangle are congruent to two angles of another triangle, then what you would be able to say is the remaining third angles in each one are congruent to each other. Everybody okay with that? All right, now these properties of congruence, they don't really matter because they're the same with everything else, so we're just going to skip filling all that in. I just wanted to finish that third angle theorem from yesterday. We are starting today talking about proving triangles congruent. This is where our proofs are going to come back in. We're going to talk today about what two types of ways we can prove these triangles congruent. And then tomorrow we'll do the proofs on them. Get one? All right, everybody ready? So we are going to talk about two different ways to prove triangles congruent. They are called SAS and SSS. Okay, these abbreviations. SSS and SAS. We will talk about a couple of more next week. These two are usually the easier ones to start with. So we're going to start with this first one, triangle congruence. If all corresponding sides and angles are congruent. Okay, if I tell you that all three angles in one triangle are congruent to the other one, and all three sides of one triangle are congruent to the other three sides, then we are able to say that those triangles are congruent to each other. However, we're not always given all of that information. We're not always told that all three angles are the same, or that all three sides are the same. So technically we're going to talk about in total 5 different ways to prove triangles congruent. The first one is called side, 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 SSS, okay? And it says if three sides, maybe I could spell a little bit better, it might work. If three sides of one triangle are congruent to three sides of another triangle, then we can say that the two triangles are congruent. So if you'll look at our picture, we have sides marked congruent, do we not? Okay, let's start with the one marking. Give me the segment on the left that's marked with one congruence mark. AB, okay. And that is going to be congruent to what's the side in the other triangle with that same marking? So if segment AB is congruent to segment ED, that's one of the sides, one pair of sides. Then let's go, what side is marked with two congruents on the left? BC. And that's going to be congruent to which segment in the other triangle? Okay, so if BC and EF are congruent, that's another side. Then what is that final pair of sides that are marked congruent in this picture? Is congruent to DF. Okay. So if segment AB and segment ED are congruent, and BC is congruent to EF, and AC is congruent to DF, then we will be able to say that these triangles are congruent by side, side, side. And what we need to do next is be able to list our congruency statement. So first of all, triangle on the left, how do you want to name that? Pick away. Any combination of those three letters. Triangle ABC? Okay. What we have to do is figure out how are we going to name that second triangle so that all the matching pieces are together. Say that again. DEF, yes. If you look at your picture, do you notice that angle A is in between the side with one marking and the side with three markings? So since we started with that angle, we want to pick which angle is in the same position in the other triangle. We chose D because D is in between the sides that have one marking and three markings. And then we went, this is how we started on this one. We started with A, which was in between 1 and 3, which is that one, is what D is. And then I went from A to B. So I went up the side that had one marking. So I'm going to go up the same side. It's pretty easy when they're drawn in the same directions, but sometimes they're going to twist and turn your pictures, and you have to pay close attention to what actually matches up. But what you guys said was correct, that ABC is going to be congruent to triangle DEF. That means angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Everybody okay with that? So if I can prove that three sides of one triangle are congruent to three sides of another triangle, then I can say that those two triangles are congruent by side, side, side. The next one is not extremely hard, but you have to pay close attention to the angles, okay? So this one is called SAS, side, angle, side. Okay, side, angle, side. So this one says if two sides and the included angle, okay, key word being the included angle. That is the angle in between the congruent sides. It says if. Give me a pair of sides that are marked congruent in your picture here. AB is congruent to what? DE. Okay, so if segment AB is congruent to segment DE, the next blank says an angle. What two angles are marked congruent in my picture? Angle. Angle B and E. And then what's the other pair of segments that you said were just a minute ago were congruent? BC is congruent to EF. So if segment AB is congruent to segment DE and segment BC is congruent to segment EF, do you notice how the angles that we marked congruent are in between those two, like where those two sides meet? That's what I mean by the included angle. It has to be the angle where the two congruent sides touch. Okay, and as long as it is, then we can say that the triangles are congruent. How do you want to call that first one? Left side, what do you want to name it? Triangle what? ABC, okay. Is congruent to. We have to name the other triangle in the same order. What would you guess? DEF again? Again, this one is relatively simple because my picture is in the same direction. They will twist and turn those so that it's not as easy to tell. So far, so good. So what we're going to do then is we're going to look at these pictures and we are going to determine if we can say that they are congruent by either side, side, side. So are all three sides congruent to each other? Or side, angle, side, that means sides and the included angle. If they are congruent, we're going to write a congruency statement. So here's kind of where I start. I look at my markings in my picture. And I always start with side, 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 because that's the easiest. Do I have all three pairs of sides marked congruent in that first picture? No. So do you think I'm going to be able to use side, side, side? No. Sometimes you can if the triangles share a side, meaning they're right next to each other. Are these triangles right next to each other, like touching? No, so they can't share a side. So my only option then is to see if they are congruent by side, angle, side. Sorry, my back is itching. Do I have two pairs of sides marked congruent? Okay, so I'm going to highlight them so that we can pay attention to our angle. What is YQ congruent to? Okay, C. And then TY is congruent to? AP, okay. And then what angles do they have marked congruent? Y, okay. So let me ask you, are each one of those angles in between my two congruent sides? Or each one of those, in each triangle, is Y in between the two sides that I have highlighted? Is it where they touch? Look at the yellow and the blue in the first triangle. Is Y in between those? It is, okay. Then in the other triangle, is K in between my two congruent sides? Yes. So because I have two sides and the included angle, then I can say these are congruent by side, angle, side. And then I have to name how they're congruent. Where do you want to start in number one? How do you want to call that triangle? TYQ? Okay. Now we have to be very careful in how we name this other triangle. Look at T. T is in between the side that has 2 marks and the side that doesn't have any marks. Yes. Okay. So in the other triangle, the angle that is in between the no mark and the 2 marks is angle P, right? So that's going to come first. P and T are in the same spot. And then we went from T down the two-sided figure to Y. So I'm going to go from P to the two-sided figure to K. And then what's last? C. Okay, those have to be in the proper orders. It doesn't have to be exactly as I have it listed, but what you do have to check. T and P are in the same position. Y and K are in the same position. And Q and C are in the same position. Okay, so that's all we have to do. We say if they're congruent by either side, 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 or side, angle, side. And then if they are congruent, we have to name that statement. Is everybody okay with that? All right, let's look at 2. How many pairs of sides do I have marked congruent there? 2. But look at that side AC. Is that the same side in both of my triangles? It is, isn't it? It's the same side it's shared. So can something be congruent to itself? So even though it's not marked, technically that side is congruent to itself. So can I say that these triangles are congruent? By what? Side, side, side. Okay. I don't even have any congruent angles marked. So how am I going to do side, angle, side, right? Now, be careful how we name it. I want you to name this bottom triangle. The one I just put yellow in. How do you want to call that one? ADC. So where we have to be careful is what comes first in the other triangle. What 2 sides is A between? 1 mark and the 3, right? So looking in that top triangle, which angle, what letter is in between the side that has 1 marking and 3 markings? Say that again. C. Okay. So I'm trying to figure out how I can show you this. Let me put that back. So angle A, we called that one first. It's in between the 1 mark and the 3 marks. So over here, 1 and 3 would give me angle C first. And then what we want to do is look at this. I went from A to D, so that's down the side with one marking. So if I start at C, where do I want to go next? To B, and which means what's last? A. Okay. So you just got to be careful when you manipulate. You can't just throw any combinations of the letters. You have to make sure the corresponding parts are in the same position. Is everybody okay with that? All right. Now, number 3 is kind of hard sometimes if you're not a good visual person. First question. I want to see what you guys can come up with. This isn't really relevant to this question. However, I'm asking, how many total triangles are in that picture? I'm hearing 3.
5.
I'm hearing 5. Okay, well, the obvious is what you guys are all seeing. That one, and that one, correct? Okay. Does that make a triangle? Mm-hmm. And then, does that also make a triangle? It does, doesn't it? So there are 5, okay? The reason I'm asking you that is because we need to be able to see the 3 small triangles, but we also need to be able to see the triangles, the big ones, as a whole. Because we are being asked if these 2 triangles are congruent. First question, how many sides do you have marked congruent here? 2. This one pair, right? Okay. Do I have angles marked congruent? Yes. But thinking about those big triangles that I just highlighted, do they share a side? Which side? MK. So that side is technically congruent to itself in the 2 big triangles, correct? So if I have 2 pairs of congruent sides and an angle, we can say it's side, angle, side as long as my angle is in between my 2 congruent sides. So let's look at this. In the right triangle, is my angle M in between the 2 sides that are marked congruent? Okay. In my left triangle, is K in between the 2 sides that are marked congruent? It is. So yes, these are congruent by side, angle, side. You just have to be able to see that they share that side. What I want you to do is write the congruency statement. Everybody try it on their paper. We're going to get different answers as long as the correct letters are in the correct positions. Start with that left triangle. How did y'all call that one? MJK, right? If you call it MJK, that's how you name that triangle? You could have done any combination of those 3 letters. Just because you didn't write exactly the same thing doesn't mean you're wrong. Just hold tight and let's see what needs to match up. If I started with M in my left triangle, that's the angle with the congruent marking, where would I have to start in the other triangle? K. And I went from M up to J, so I'm going to go from K up to what? L. And then back to M. So as long as your K's and M's are in the same in both triangles, and your J and L are in the same. Okay, it doesn't matter if they're not exactly the same order as I have, as long as M matches with K on both ends, and then your J is in the same place as the L. Everybody okay with those? All right, let's take a look at this last picture. Again, the only 2 ways that we can say triangle is congruent is if it is side, side, side. So all 3 pairs of sides are congruent to the 3 in the other. Do I have 3 pairs of sides marked congruent here? Do I have all 3 sides marked congruent in this picture? Okay. I do have 2 sides and an angle, yes? Does that automatically mean it is side angle side? No, because that angle has to be where? It has to be included in those sides, in between the two sides. In my triangle on the left, I have SV and I have SU that are marked congruent. The angle in between that is what? No. Look at the angle where those two greens touch. S. That's the included angle. Is that angle marked congruent? It's not, is it? Okay. And then in the other triangle, TW and UT are marked congruent. But what's the side that's in between those? In between the two blues, where do they touch? At T. Is that angle marked congruent? Okay. So I do have two angles marked congruent. They're just not the included angles. So can we say that these two triangles are congruent? Okay. Are all three sides marked congruent? No, so we can't use side, side, side. In order for me to use side, angle, side, it has to be the side, the included angle in the other side, and we just determined that that wasn't the case here. So can I say that these are congruent? No. Okay, look, we have a side, and then we have an angle. That's not what we said. That is a bad word or a bad word backwards, either way you look at it, and we don't use that combination of letters. We don't put SSA and we don't put ASS, okay? That usually gets a joke, or a giggle or something. Come on. Okay, thank you. So your combination of letters should not be in that order. It should not be a side, side, then an angle. It should be a side, an angle, and a side. What I mean by that is if I have a picture, wherever I start, I have to go in the same direction clockwise, side. The next thing I come to is an angle and then a side. Whereas in this one, I had a side, and then an angle. That is a bad word backwards, so we're not going to use that combination, and that cannot prove our triangle is congruent. And if they're not congruent, is there any reason for me to make a congruency statement? No. So that's all I have to do is say, no, they're not congruent. And I'm done with that question.